Hi everyone, my name is Dheekshaw Gopinath. Today we'll be going over the math Kangaroo questions for levels 3 and 4. Let's get started. Question 1. Zoe lit 5 identical candles all at the same time. They stopped burning at different times and now look as shown in the picture. Which candle stopped burning first? Okay, so if you guys have ever seen a candle before, you know that candles that burn the fastest and the most melt the most, and therefore are very short. That being said, candles that burn least don't melt as much and therefore are tall and tend to stay their typical height. So, as you can tell from this picture, D is the tallest candle, and we can infer that it stopped burning first because it didn't melt as much, which is why the answer is D. Moving on. The 2 kangaroo coins with question marks on them have the same value. What is this value? For this, we can solve this question like we'd solve any other algebraic question. We can replace the question marks with the variable x, which is what I'm going to do. So I'll rewrite it, 20 plus 10 plus question mark, which is replaced with the x plus 1 is equal to 51. Now we can solve it like we'd solve any other algebraic equation. I combine like terms, 20 plus 10 plus 10 plus 1 gives me 41 plus x, which is 2x, which is equal to 51. Subtract 41 from both sides. 2x is equal to 10. Divide the entire equation by 2. X is equal to 5. Since x is the same as the question mark, we can say that the value of the question mark is 5, and therefore the answer is C. Hopefully everybody understood that. Let's move on. A gray circle with 2 large holes in it is put on top of a clown-faced astronaut. The gray circle is turned around its center. Which 2 numbers is it possible to see at the same time? So there's a short way and a lengthy way to do this problem. For the sake of explaining and to make the problem simpler, I'm going to take the lengthy way of solving this problem. So what I like to think of this problem as is making pairs. So from this image we can see right here, we can see that 1 and 5 are a pair. Then if we move the gray circle 1 unit over, it would be 2 and 6. 2 and 6 would be a pair. Like that, 3 and 7 become a pair. And I could just keep going. Like 4 and 8 is a pair, 5 and 9 is a pair, 6 and 10 is a pair. If you guys notice, there's a pattern. We're just adding 4 to each, the smaller number. So 7 and 11 is the pair. And lastly, 8 and 12 are. Now, if you can see from the answer choices, which of the following matches our pair? If you compare and contrast, you see that 5 and 9 and 5 and 9 match, which is why this pair is possible to see at the same time, and that's why it's our answer. Next problem. Excuse me. Okay, Alice has these puzzle pieces. Which 2 pieces can she put together to form this square? So this is a 2-dimensional square, full and through. So therefore, we cannot have any overlapping puzzle pieces, and every single unit of the square needs to be covered. Let's start off with trying out each of these answer problems. With these kind of questions, you need to make a visual or mental image, and it doesn't hurt to sort of draw it out and make a diagram so you can get a better understanding. So 1 and 2. If we put figure 2 on top of figure 1, like so, I'm drawing it so you guys can see better. We can see that it's almost perfect, except for this area of overlap right here. Figure 2 overlapped this unit over here, which is why 1 and 2 cannot be an answer. Okay, next one, we can try B. Do figures 1 and 3 work? I'm just gonna draw to show you guys. Obviously, we can see that there is a ginormous amount of overlap, as you can see over here, which is why figures 1 and 3 do not work either. Moving on, let's try figures 1 and 4. So this is figure 4. Let me try drawing it here like so. As you guys can see, there is no overlap whatsoever, and the figure completely fits within the empty space within figure 1, which is why the answer to this problem is C. For problems like these, where you have to try out each of the answer choices, I recommend coming back once you finish the rest of the test to try out the other answer choices that you haven't tried out yet, just so you can get a more clear understanding of whether or not your answer is correct. Let's move on. A light engineer in the theater turns the lights on and off. She uses the plan shown. How long in total are exactly 2 of the lights on at the same time? So this question is asking how many minutes are exactly 2 lights on at the same time, not 1 light or 3 lights on, 2 lights on. So like for example, the time between 0 minutes and 1 minute does not work because only 1 light is on. But between minutes 1 and 2 does work because there is the green light and the blue light on at the same time. Those are 2 lights on at the same time. Between minutes 2 and 3, it does not work because there are 3 lights on at the same time. 3 and 4 works, 2 lights on at the same time. 4 and 5 works because once again, 2 lights on at the same time. 5 and 6 also work because 2 lights are on at the same time, orange and blue. 6 and 7, the green and the blue lights are on. 7 and 8, there are 3 lights on, so that would not be factored into our answer. 8 and 9, it does work because there are only 2 lights on. 9 and 10 does not work. 10 and 11, however, and 11 and 12, both of them work. So now let's count up all the times that we counted 2 lights on at the same time to get our final answer. So 1, 2, 3, 4, 5, 6, 7, 8, which is why the answer is 8. Next question. Arab folds the transparent paper along the dashed line. What can you see there? For these kind of problems, once again, it's helpful to make a mental image of what we think the answer might be, but it's also a lot easier to just sort of try to visualize and draw out what the question is asking. So that's what we're going to do. So when Arab folds this paper, there will be a line here, there will be one here, a line will show up here. Remember that it's like flipping over, so it's going to be a little bit of the opposite, if that makes sense. So then you put the box right here. You can't really read that, but it says 406 from here. So that's why the answer is E. Moving on. Anna has 4 discs of different sizes. She wants to build a tower of 3 discs so that each disc is smaller than the disc below it. How many different towers can Anna make? Okay, so there's one large green disc. Actually, I can use colors, so let me try using that. There's one large green disc. Above that, I'm ranking it in terms of size. There's one red disc. The smaller one is the blue disc, and the smallest disc is the orange disc. It's probably different for you guys, but I digress. So we want to build towers of 3 discs in such a way that each disc is smaller than the disc below it. So what sort of patterns can we see? I can think of a couple. So we can have the green, the red, and the blue on top. That would be this. Each disc is smaller than the disc below it, except for the green. Another combination that could work is the orange, the blue, and the red. So orange, blue, red. That also works as a combination. Now, although this seems like the right answer, there's also a couple other combinations that we can make. Let's say we remove the red disc. Then another combination where each disc is smaller than the disc below it is orange, blue, and green. But let's say we remove the blue disc but keep the red disc. the combination would be orange, red, and green. Those are the amount of combinations that we can make total in such a way that each disk is smaller than the disk below it, which is why the answer to number 7 is 4. It's always good to come back and recheck your answers in these kind of questions, but let's move on. Number 8. Danny glued the 2 pieces of paper without cutting them on top of the blank circle on the right. What can he not make? Okay, so for this problem, how I like to approach this is see how if each of these shapes can be shown in the images here. Obviously, this black circle thing over here can be seen in all of the images. It's over here, it's over here. Since it's the full circle, we can just assume that the rest of the other 2 pieces of paper are overlapping. Next, let's move to the brown half circle. So in this picture, the brown half circle is shown. It's just covered by the white quarter of the circle. I'm going to be calling this thing the quarter. So over here, the brown half circle is shown. So this one is a shape that he can make. Over here, the brown shape is shown. The brown shape is shown, and the quarter is shown. It's just over here, and it is covered by the brown half circle. He can make this image. Next image. The brown half circle is here, the white border circle is here, so he can make this image, that's for sure. In this picture, it may look like the shapes are not as clear, which they're not, but the brown half circle can be shown right here, and the quarter is just covering over that brown half circle. So we can make this image. However, for image E over here, if we look at the brown half circle, we see that it cannot be made by the shapes that are shown over here. It seems that the brown half circle has been cut because it's the brown half circle seems to be in quarters rather than a half circle, which is why we cannot make this image, which is why that's the answer, because that's what shape can he not make is the question. Next question, number 9. The shape on the right is covered with the 5 pieces below. Which piece will cover up the dot? For this question, it does tend to get a bit theoretical. So let's try to start with what we know. So if I look at this image over here, I'm trying to find which of these pieces will be covering up this dot over here. So let's try plugging in pieces. I know that this C piece over here goes right over here because that's the only one where a full square, and 2 triangles can fit. That's the only place. See you soon. Next. Sorry, let me. So that's why I believe that the C piece should go right here. Moving on, let's try to fit anything else. So we're going to assume for the sake of the simplicity of this question, let's assume that there won't be any rotating necessary. We'll just see the pieces as is. Okay, so because of what I just said, keeping that in mind, this piece appears to be very vertical in shape. So that's why I believe that we should put it right over here in the vertical side of this shape. So when we put that in there, now we have one piece that's shaped like a longish triangle. We already plugged in C and D. So for this triangle shape here, it appears to be the most like B. So when I put B in here, it'll fit right there. Perfect. Now I'm trying to plug in E and A. So E and A will obviously fit somewhere over here. I want to make sure that both of these pieces can completely encompass this entire empty spot over here. So I think that E should go over here because if I were to plug in A into this area, it will not be able to fully cover up this entire piece. So Once we plugged in E, the only option we have left for this area is A, which fits in perfectly and fully encompasses the figure. A is the piece that covers the dot, which is why the answer to this question is A. Moving on. Number 10. There are 6 weights: 1 kilogram, 2 kilogram, 3 kilogram, 4 kilogram, 5 kilogram, and 6 kilogram. Amy puts 5 of these on the scales and puts 1 weight aside. The scales balance. Which weight did she not put aside? Wait, which weight did she put aside? So these are the kind of problems which I like to call brute force problems, because it doesn't have much of an algebraic approach to it. You mostly just try all of the options to try to see which of the options can fit this scenario. Let's try to see. So we know from the image that the 5 kg weight will be on this side and the 6 kg weight will be on this side. There are 3 total weights on this side and only 2 weights on this side. So I'll start off by plugging in. My mental process in this problem is that since I have a lot more weights on this side, I'll have to take smaller numbers on this side than I would for other sides, because like a lot of a smaller number is the same as a little of a big number, if that makes sense. Okay, so if I try 1 and 2, for example, and 5 plus 1 plus 2 is 8 on this side, 6 plus something. So these have to be equal to each other. X's only option is 2. However, we already used the 2 kg weight, so we can this cannot be a scenario. Likewise, you should try all of the possible combinations. Next, let's try 2 and 3. So 5 plus 2 plus 3 is 10, and 10 is equal to 6, and this is x. 6 plus x is equal to 4. So it is possible to plug 4 into here. So now the only remainder weight, we already used the 2 weight, 3 weight, the 4 weight, and the 5 and the 6 weight. The only remaining weight is the 1 kg. So this is the 1 kg weight that she put aside, which is why the answer to this is A. Next question. Andrew has a 60 centimeter ruler. Unfortunately, some of the markings have faded. He can still measure the length 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, 50 centimeters, and 60 centimeters using his ruler only once. Keep that in mind. That's really important for this question. Which is his ruler? Okay. This problem requires a bit of theoretical thinking. So Andrew is only allowed to use his ruler only once to measure all of these lengths over 2. Theoretically, that would be really difficult. For example, if you had a 10 and a 20 and you wanted to measure 30, you would use the ruler twice to measure 20 centimeters and then measure another 10. But for this question, you're only allowed to use the ruler once. So how would we come about that? If we try 10 and 30, if we want to measure 50, that would be like, for example, if for the first question, if we wanted to measure 10 and 30, and we wanted to measure 50, for example, if we take this first ruler over here, and we have 10 centimeters and 30 centimeters. Let's say we wanted to measure 30, for example. 40, for example. That would be very difficult to measure if we weren't allowed to use the ruler twice. So that we would not be using this one. This one works for 10. We can theoretically, the human mind can process what half lengths seem like from a distance. So From this ruler, we can tell that this is the 10 centimeter, this is the 30 centimeter, this is the 50 centimeter, this entire thing is the 60 centimeter. So for now, this answer works. Let's try to look at the other options. Using this ruler, can we theoretically measure 20? The answer is no. So this one does not work. Using this ruler, can we, for example, measure 40 by using the ruler only once? That does not work. So that we're not going to use that answer. And for this one, like, will we be able to measure 30 by using the ruler only once? The answer is no. So that's why the answer to this question is B. Moving on. There are 7 houses north of Road A, 8 houses east of Road B, and 5 houses south of Road A. How many houses are west of Road? Excuse me. For this question, we should try to sort of draw it out and visually see it. It's a good thing that we were given a compass for this question. So 7 houses north of Road A. That means 7 houses above Road A. So 1, 2, this entire thing is Road A over here, by the way. So 1, 2, 3, 4, 5, 6, 7. 7 houses north of Road A. 8 houses east of Road B. So that would be over here on this side. So we already have 4 over here. So 1, 2, 3, 4. 8 houses east of Road B. 5 houses south of Road A. So there's 1 house right there. So south will be below Road A. So that would be 5 houses. How many houses are west of Road B? So they're asking how many houses are to the left of Road B. If you look at this compass, the west is in this direction. So how many houses are in the west direction? That answer would be 1, 2, 3, 4. 4 houses are west of Road B. Moving on. There are 8 cars waiting in a line for the ferry. Every car contains either 2 or 3 people. There are 19 people in total waiting for the ferry. How many cars contain exactly 2 people? Okay, this problem we can solve algebraically. Let's set up 2 equations. One equation is x plus y is equal to 8. So 8 total cars, we're setting up the equation to equal to 8. The other equation will be 2x plus 3y is equal to 19. Now that we set up the equation, let's solve for it. So we multiply this entire thing by 2. So that would give us 2x plus 2y is equal to 16. 2x, I'm rewriting this over here, by the way. 2x plus 3y is equal to 19. And then we subtract the entire thing, so we get negative y is equal to negative 3. So y is equal to 3. That means there are 3 cars with, if we look at this equation here, 3 cars with 3 people. And let's plug in the y variable into this equation. So x plus 3 is equal to 8. X is equal to 8 minus 3, which is equal to 5. So 5 cars with 2 people, which is why the answer to this question is D. Moving on. The metro line has 6 stations, A, B, C, D, E, and F. The train stops at every station. When it reaches one of the 2 end stations, it changes its direction. The train engineer started driving at station B, and her first stop was station C. Which station will be her 96th stop? So a common mistake for this problem is people tend to believe that they divide 96 by 6 and solve from there. But if you notice, if you, for example, if the bus were to start from station A and go to station F, it's 1, 2, 3, 4, 5. The train makes 5 stops. So we have to keep that in mind. So 96 divided by 5. For those of you who can do math quickly, it's 19. 19 remainder 1. So she moves back and forth 19. She goes back from each stop 19 times. and then moves, and then there's one more remainder, she moves one more station. If her first stop is at station C, then if you add one, it becomes station D, which is why the answer to this is D. Moving on. Sam walks through the two-story maze from the entrance to the exit, passing 3 wall stickers. In what order will she see them? Okay, this problem has a lower floor and an upper floor, so we're going to have to walk through the maze ourselves and see where we can find each sticker. Let's get started. So first she goes in this way, then she goes through this door. That's the only door available. Then she has to walk upstairs. Upstairs, we have to move here. We have to move and go through here. We go here, we see this hyena sticker, I think. So the first sticker is a hyena. So automatically we can cancel out this answer choice, and this answer choice, because we know that the hyena is the first thing that we see. Moving on, we go downstairs here. We go downstairs, go this way, go through this door, then we go through this door. Then we go here. Next, we see the rhinoceros. So automatically, we know that the next sticker is the rhinoceros sticker, which is why the answer will be 8. Typically, try to go through the entire maze if you have time. If you're short on time, then this is the best approach for you. Moving on. Okay, problem 17. 6 beavers and 2 kangaroos are standing in line. Among any 3 consecutively numbered animals, exactly 1 is a kangaroo. Which of the following numbered animals is a kangaroo? So 8 spots. So 1, 2, 3, 4, 5, 6, 7, 8. There are 6 beavers and 2 kangaroos in the line. So among any 3 consecutively numbered animal, exactly 1 is a kangaroo. So really try to think about that. What does that mean? We can, for this problem, for the sake of simplicity, I'm going to be using the answer choices to explain. So for example, if the animal in placement 1 was a kangaroo, it would go as kangaroo, beaver. Question number 17. Six beavers and 2 kangaroos are standing in a line. Among any 3 consecutively numbered animals, exactly 1 is a kangaroo. Which of the following numbered animals is a kangaroo? Okay, so there are 8 spots, right? 8 animals. 6, 7, 8. Okay, so 6 beavers and 2 kangaroos. Among any 3 consecutively numbered animals, that means like 1, 2, 3, like 2, 3, 4, 3, 4, 5, like that. Exactly 1 is a kangaroo. Which of the following numbered animals is a kangaroo? So let's just start off this problem strong by checking off all of the answer choices. If question 1 was a kangaroo, placement 1 was a kangaroo, then placement 2 and 3 would be beavers, but placement 4 would have to be a kangaroo. I'm going to number these real quick. Let's slant them. Okay. Placement 4 would be a kangaroo. Next, placement 5 would have to be a beaver. Placement 6 would have to be a beaver, but there are no other kangaroos left. Placement 7 and 8 would have to be a beaver. This does not work because it does not follow this rule, that among any 3 consecutively numbered animals, exactly 1 is a kangaroo. Because among number 5, 6, and 7, or number 6, 7, and 8, there is no kangaroo, which is why question number 1 does, the answer as 1 does not work. Next, let's try kangaroo placement of 2. Oh, let me draw the distance again. 1, 2, 3, 4, 5, 6, 7, 8. So placement 2 is a kangaroo. So that means placement 1 would be a beaver, placement 3 would be a beaver. Placement 4 can afford to be a beaver, yes. Placement 5 has to be a kangaroo. Placement 6 has to be a kangaroo, 6 is a beaver, 7 is a beaver, and 8 is a beaver. So this one is so close, except it does not follow the 3 consecutively numbered animals exactly 1 is a kangaroo rule for the placements 6, 7, and 8, because among these consecutively numbered animals, all of them are beavers, there are no kangaroos, which is why this answer does not work either. Next option, kangaroo placement at number 3. Let's try that. Okay. So kangaroo placement over here. So that means this is a beaver, this is a beaver, and number 4 is a beaver, number 5 is a beaver, number 6 has to be a kangaroo, number 7 and 8 are beavers. If you guys look at this closely, we can tell that this one does follow the rule that among any 3 consecutively numbered animals, exactly 1 is a kangaroo. Because 1, 2, and 3, there's 1 kangaroo. 2, 3, and 4, there's 1 kangaroo. 3, 4, and 5, there's 1 kangaroo. 4, 5, and 6, there's 1 kangaroo. 5, 6, and 7, 1 kangaroo. And 6, 7, and 8, there's 1 kangaroo. Which is why the answer to this one is C. Moving on. Anya wants to paint the circles in the picture. She wants to paint any 2 circles connected with a line of different colors. What is the smallest number of colors she needs? So for this problem, I figured the wisest decision to start off is starting with the circle that is connected with the most amount of other circles. So if in this case it's the middle one, let's say the middle one is black, for example, then the one over here has to be a different color, and the one to the right of it on top has to be a different color. The one to the bottom left has to be a different color, and the one to the right, bottom right, has to be a different color as well. However, for the sides can both be black for this question. I know the question is worded weirdly, but it says that any 2 circles connected with a line at different colors. So even though both of these are like the same, even though both of these are the same color and are connected to the blue circle, it just needs to be connected with a line, which is why that rule is not applicable, in case anyone found that confusing. That's why the answer, because there are 5 different colors, 1, 2, 3, 4, 5, the answer to this question is 5. Next question. Rebecca folds a square piece of paper twice. Oh, this one, Rebecca folds a square piece of paper twice. Then she cuts off one corner. Next, she unfolds the paper. What does the paper look like once unfolded? For this one, once again, we have to be sort of theoretical about it. So when you fold a paper, you fold it in half, you fold that in half. Now, what Rebecca wants to do is she wants to cut off the corner over here. So when you cut off the corner, you're also cutting off the corner piece for this side as well. And when you unfold it again, it will look like a diamond. This problem mostly just requires some visual thinking, so that's why the answer to this question is B. It's a good idea to draw this one out, but unless you have a good idea of what it looks visually, maybe you can also, if you have a scratch sheet of paper, you can try solving this problem that way too. That helps as well. Okay. Hermione, Harry, and Ron, Harry Potter, always walk into the common room one at a time. Hermione is never first, and Harry is never second, and Ron is never third. In how many different orders can they walk? So let's try to draw a visual diagram. Or just get an idea of where each of them stand in terms of places. So Hermione always has to be second place or third place. Harry always has to be first place or third place, and Ron always has to be first place or second place. In how many different orders can they walk? Okay, let's try to satisfy this. So Harry, which I will depict with an H, Harry can be first once. Hermione can be Hermione cannot be Hermione can be second, but Ron cannot be third. So after Harry, it's Ron, and then last we have Hermione. So that's an order that we have. Another order that we can have is Ron is first, Hermione is second, and Harry is third. That's an order that we can have. Apart from this, there doesn't seem to be any other better option, which is why there are only two different orders that they can walk in. There isn't really any other order that they can walk in that can satisfy the terms that we have over here, which is why the answer to this one is 2. Moving on. There are 5 clocks on the wall. It is known that 1 clock is an hour fast, 1 clock is an hour slow, and 1 clock shows the correct time, and 2 clocks have stopped. Which clock shows the correct time? So we're going to, I'm going to solve this problem with a slightly more algebraic approach. There are obviously easier and more lengthy ways to solve this problem. This is just what I find simple for me. So I'm going to depict the correct time as X. That will be the correct time. The clock that is 1 hour slow will be depicted as X minus 1. And the clock that is 1 hour fast will be depicted as X plus 1. So which clock shows the correct time? Let's try writing down these times over here. So this is 6 o'clock, this is 2 o'clock, this is 4 o'clock, this is 3 o'clock, and this is 7 o'clock. So which one of these follows this sort of consecutive time? So like we want to find it so that they're consecutive, right? So in this case, 6 and 7, they are consecutive with each other, but we need to have 3 in a row that are consecutive, and they don't follow that. So the consecutive will be 2, 2 o'clock, 3 o'clock, and 4 o'clock. 1 o'clock is an hour fast. That's this one. 4 o'clock is an hour fast. 2 o'clock will be an hour slower, and the right time will be 3. So that's why the correct answer to this question is D. Moving on, number 21. Okay, Adam and Brenda have 9 marbles each. Together, they have 8 red and 10 blue marbles. Brenda has twice as many blue marbles as red marbles. How many blue marbles does Adam? Excuse me. So for this one, we need to make a rule. So Brenda has twice as many blue marbles as red marbles. So if we think about this, Brenda has 9 marbles total. And that's 2 red marbles plus 1 blue marble. X depicts the marbles that she has. So if we solve for this, we get 3x is equal to 9. So there's an easier way to approach this section. So Brenda has 9 marbles total, okay? So if she has 1 marble, if she has 1 red marble, she has 2 other blue marbles, which means she has 3 marbles total. If Brenda has 2 red marbles, then that means she has 4 blue marbles, so that means she has 6 marbles total. But if Brenda has 3 marbles and she has twice as many blue marbles, which is 6 marbles, she'll have 9 marbles total. So Brenda has 3 red marbles and 6 blue marbles. That's how I like to think of this question. Now we need to figure out how many blue marbles Adam has. So there are 10 total blue marbles if you add up what she and Adam both have. And so we can just solve this problem by doing 10 minus 6, which is equal to 4. And that's why the answer is B. Next question. Chloe has two machines. When she puts a square sheet of paper in machine R, it turns the paper 90 degrees clockwise. 90 degrees clockwise, keep that in mind, guys, it's this direction. Like turning this way in like the shape of the clock. When she puts the paper in machine S, it stamps the paper with a clover. In which order are the machines used to produce the result shown? Okay. This problem requires some visual imaging and rotation, but we can always also do this problem by drawing it out as well. Okay, so the square starts out like this with a little thing over here. Then we can assume that the clover started out as is, but it was rotated once clockwise. And we can tell from this image that the square was rotated clockwise 2 times because the little black box thing is over here. So we want the final result to be this with a clover. Okay. So for the sun, over here, we know that. Okay. So now we need to find what happens here, and what happens here. Let's try to visually think about this, guys. So we want to assume that the clover was stamped over here like this. And it was on the thingy was over here. So that means that this square got rotated clockwise 90 degrees once. So that means it had to go through R over here to rotate over here. Then it got stamped with the clover over here. So it's an S. This is an S over here. And for this box, within this machine, the entire square was shifted over 90 degrees again. And that happens in machine R, which is why the order will be R S R. And that's why the answer for this question is B. Next question. Yay, another brute force problem. Teacher Claire wants to write the numbers 1 to 7 in the circle. Inside each circle, she writes one number. She wants the sum of the numbers in 2 neighboring circles to match the number shown on the connected line. What number must she write inside the green circle? Now, I suggest you guys go over that problem one more time to get a deeper understanding of what it's asking for. Excuse me. So for this problem, we can just start off by trying to write any number and from the answer choices inside of the green square and starting off from there. So we know that the number should not be so high or so low that it doesn't add up to the corresponding number, if that makes sense. So for example, if we start off with 1 over here, then we need 5 over here so that 5 plus 1 adds to 6. Then we need 4 over here so that 5 plus 4 adds up to 9. 4 over here so that 4 plus 4 adds up to 8. We keep going like that, right? But you guys will notice that once we come to the end over here, 2 plus 1 does not add up to 9, which is why we cannot add 1 to the green circle since it will not work. Let's try starting off with, let's try starting off with 2. If we try 2 here, 2 plus 4 out of 5, 3, 4, 5, 3. 3 plus 2 does not add up to 9. Once again, this problem does not work as, this solution does not work as intended. Let's try a different one. 3. 3, 3, 6, 2, 5, 4, 4. 4 plus 3, once again, does not add up to 9. That answer solution does not work. Let's try 4 instead. 4, 2, 7, 1, 6, 3, 5. 5 plus 4 does add up to 9, which is why the answer to this question is 4, because writing 4 over here is the only possible solution that we can have to fit the entire circle and the rules that follow. Moving on, number 24. Maria has shaded exactly 5 cells in a 4x4 grid. She challenges 5 of her friends to guess which cells she has shaded. The grids that they have drawn are shown below. Maria looks at them and says, one of you is right, and each of the rest of you has 4 cells correct. Which is the correct answer? So for this question, my first advice is to look for certain features that overlap. In this case, something that's common among all of the squares that are given are these 3 cells over here. All of these 5 have these 3 in common. Next, let's try to look for more similarities. What are some other things that they have in common? 4 out of the 5 of these have this in common, so we can assume that it is correct. Now, C was not correct, but it's not good to cross it out completely. Instead, let's try to look at what C has that the others don't have, and maybe that can give us a sort of answer to what might be correct. So if we look at C, we know that C is not correct, but because one of these 2 cells does not work, the other one is correct. It's sort of like the process of thinking this through. And so, do any of the other squares have this cell available? The answer is no. None of the other squares use this cell, so that means this cell is not correct. So, let's try looking for this cell. That means this cell is the correct cell. Do any of these squares have it? The answer is yes. E has this cell shaded in, which is why E is the correct answer for this question. All right, thank you guys so much for watching. I hope you guys were able to solve all of those questions. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the